Okay, well, maybe I will start us off. And as I go through my little spiel, we'll have the rest of our attendees kind of slowly log in and join today's session. So I just want to start off by thanking you all for joining us for the webinar today. For those who are new to SRIA or SSRIA, it stands for Smart Sustainable Resilient Infrastructure Association. And our mission is to accelerate the adoption of innovative low carbon solutions for buildings through really a collaborative and industry-led approach that we believe will really demonstrate Canadian leadership and drive economic development. We're moving our mission forward by funding projects that demonstrate innovative technology, products, or processes that, of course, reduce GHG emissions. And we already actually have 9 really exciting projects funded and underway, and are now accepting a 4th round of project applications. So if you have a project that is applying an innovative solution to reduce GHG emissions or energy use, or even a product or technology that you would like to demonstrate in a building, please visit our website to learn more, and I'll make sure I post that in the chat box, as well as my contact information. So you can certainly feel free to reach out to me. I'm happy to meet with anyone, give you more details about our organization and about that funding opportunity. For today, we have a really great presentation and discussion planned that will focus on smart buildings, as that is really the starting point for us. But as we know, every building is also part of a community. So the discussion today will also start to explore how these buildings become part of smart grids and smart cities. So we'll start with a presentation by Mark and Wade of Siemens about what smart buildings are and some of the technology available that is reducing energy use of buildings. And one of the technologies that they'll touch on is the dynamic VAV optimization, which is actually being demonstrated in Edmonton at ATB Place as part of a SSRA funded project. So we're excited to have that project underway and see the results from that technology. We'll then hear from Morgan McDonald of Ledcor, who will share the contractor's perspective on smart buildings and sustainability before we move into a discussion and Q&A. Please do add your questions into the chat box throughout the session, and then I can kind of organize them as they come through, and we can add those to our discussion and the Q&A at the end of the session. I have everyone automatically muted, and I don't think anyone should be able to unmute themselves to avoid any background noise or distractions. And so with that, actually, I will pass it over. We'll start with Mark. So Mark is the Energy Services Business Development Manager for Siemens Canada. For more than a decade, Mark has held various positions in the energy and carbon management industry in Canada and the UK, actively seeking to develop, implement, and verify initiatives that lead to a more sustainable future. And then I'll also introduce Wade Reda, who leads the Intelligent Building Initiatives with Siemens Canada, supporting infrastructure owners along their smart building journey. In this role, Wade is involved in bringing not only smart but intelligent solutions into practice from the grid to the building. So take it away, Mark.
Thanks, Pam. And thank you everyone for joining. We're going to be obviously talking about smart buildings and how that can play into sustainable buildings as well in the sustainable future. As many of you know, smart buildings, it's a hot topic, still fairly new, and I think a lot of people are navigating their way around, what really is a smart building? What does it mean for me? And we'll happily touch on some of that today. And I really look forward to questions and conversation on the back end. So why, I'd say from my perspective, fairly self-explanatory. We expect more out of our buildings these days. We need to be comfortable in them. We're more connected as a society, and we've got that expectations for the buildings that we occupy day in and day out. But there's also a really strong opportunity for energy efficiency, carbon reduction by using those same technologies. In many cases, you can see the numbers on the screen, just using the buildings that we have today better, there's a great opportunity for carbon reduction. And then bringing smart technologies and that additional input into play, it allows us to do even better. When we think about smart buildings, I think there's a tendency to just by default think about those brand new buildings that look fantastic and are outfitted with everything. And that's the case sometimes, but more often than not, we've got our existing built infrastructure, and we don't want to just let that sit idle. We want to improve it as well. So I think it's really important to consider, how does a smart building and smart building technologies come into play for existing facilities? Um, there's plenty of ways to do it. Some pitfalls of doing it as well, or certain approaches that could be taken. One thing that I like to keep in mind is to follow a certain path, to make sure that what we have now, we're using it properly, we're using it efficiently, and that's where something like retro commissioning comes into play. That type of exercise not only delivers the greatest efficiency you can get out of the existing building, but it can also identify some of the gaps or opportunities for improvement that can then move forward as a building goes through its typical capital planning and life cycle improvements. You can have the results from that retro commissioning exercise in mind. Also, this North Star of where you'd like that building to get to eventually, that smart building that's really efficient, and make sure that capital upgrades are actually checking as many of the boxes as possible. And then ultimately, you arrive at that building that it's efficient in the background. That's not really something that most people see, but it's also a smart building, a building that the occupants feel connected to. They feel that their personal needs are being tailored to, which isn't necessarily the case in most buildings today. It's a journey. I think that goes without saying. It certainly is. Most buildings today, commercial, institutional buildings, they would fall into that integrated building category that we see here. There's almost always some degree of automation, building control, technologies like diagnostics and fault detection. Those have been scaled up over the last several years. So many buildings have moved from that traditional building to integrated. Not everything by any means, but then you also have buildings that maybe just by virtue of being newer, or some forward-thinking building owners and managers, they've taken that next step to at least bring smart building technologies into play. But very few are, that futuristic building that we imagine when we think smart buildings. But the reality is that most of those technologies are available today. Some a little bit more commercialized than others, but I think you'd be surprised if you canvass the market and really dug into it. You'd be surprised at what's actually available to us today. Now, regardless of where a building falls on that spectrum, when we want an energy efficient and sustainable building, there's a few core things that we need. We want that building to deliver what's needed. So the building, it's not useless, but it's not doing its job if we don't have adequate light levels. We don't have proper ventilation. It's uncomfortable. So it's important that we remember the building's there for a reason. People occupy it, and we need to make sure that everything that is required is satisfied. We don't want to deliver anything more than what's needed. What I mean by that is, meet our ventilation requirements in terms of code, comfort. Sometimes, like the times that we're in right now, there might be a near-term need or short-term need to deliver more ventilation than what's typically required. But under normal circumstances, we don't want to be running a building at 100% fresh air all the time. It's a significant energy penalty for really minimal returns once you get to a certain point. And that holds true for all systems within the building. So we want to deliver what's needed, don't deliver extra. And everything that we do it efficiently. So all the equipment that's running in the background, make sure that it's delivering that conditioned air, that fresh air, the lighting levels as efficiently as possible. Lighting is probably the best example of that. You can have the same light level or lux output from some old fluorescent lighting or new LED lighting. One of them is more efficient than the other, but they're both delivering that same end result, being the light level. But we can run into a problem. It's all good in theory, but how do we know what it is that's needed in the building, especially when we think about how a building gets used over time? It's dynamic in terms of the environment. What do we need today or this hour versus 2 years ago or in the future? How do we know what's going to be needed next? And that could be near term or short term. If we think near term, we might satisfy building comfort for right now. But if we know that there's a change in weather coming, it's predicted to be a very hot afternoon, can we change our operation in the morning, still satisfying our morning comfort conditions, but better prepare ourselves for the afternoon? And lastly, what is efficient? We're going to be talking today, what's a smart building? But even what is efficient, because that could have different meanings for different users. It could be energy efficiency, lowest gigajoule per square meter. It could be cost efficient, lowest energy cost. It could be carbon efficient, being the lowest carbon building possible. And it's okay for that to vary from building to building and person to person. But if we're trying to be efficient, we need to know what our efficient and our definition of efficient is. So how is an energy efficient smart building different from just an energy efficient building? The number one thing, it's data. There's more data flowing in a smart building and greater access to that data. And it allows us to be more adaptable and really go to that next level of demand-based control. So by knowing what's happening in the building, who's in the building, occupancy levels, we can do a better job of operating ventilation systems, heating, cooling, lighting, make sure that it's doing that job of what we want, right? It's delivering what's needed based on how many people are there, who's there, what, how they even feel. If people are feeling too hot, that means we need to make it colder. It's more people centric that way. But the big thing is make use of that data. And in our view, there's the difference between a smart building and an intelligent building is that a smart building has a lot of data. An intelligent building makes use of it, right? And really that's what we want. The smart building, it's great, it's cool, a lot of interesting things happening, but our end goals, I'd say, are a lot more tailored to an intelligent building where we can make use of that data. And I mean, from an engineering perspective, data is great, but it's becoming almost an issue that there's so much of it, you can drown in it really, if you don't have systems in place to make use of it. So now that we've talked a little bit about smart buildings, that journey, we're going to touch on a few specific technologies, some things that Siemens has in the marketplace right now, and then I'll pass it over to my colleague Wade, and we're going to zoom out a little bit outside of this focus from just what's happening inside the building to the grid and that interaction between. So the first one we're going to talk about is called dynamic VAV optimization. This is what Pam alluded to earlier. There's an ongoing project that SSRIA is supporting in Edmonton with ATB Tower, and dynamic VAV optimization. It's, as the name says, it's VAV, that's variable air volume for anyone who doesn't know. And it's really just a very common system type for ventilation in commercial buildings. What we're doing with dynamic VAV optimization, or DEVO, is applying machine learning and artificial intelligence to the way that we control these systems. The conventional building automation system does some things very well. That would include having a set point and controlling to it. So if you tell it, I would like it to be this temperature, it's really good at making a space that temperature. But it runs into some problems when things get more complicated. When we've got, we're looking at forward prediction. So instead of reacting, we want to predict. Typically in these systems, and just about anything, if you think even your thermostat at home, it waits until it gets a little bit too hot or too cold and then makes a change. We like to get to this point where we adjust and we control before it actually gets too hot or too cold. Nonlinear optimization. So in a VAV system, there's a few things that we can change. And the BAS, like I said, it's really good at having that set point and controlling to it. But when we've got multiple variables and we're trying to decide what the set point should be on the fly, changing all of the time, that's something that artificial intelligence and machine learning does far better. So we can move that complex task for the automation system, take that to the cloud, let it do its thing, do what it's good at, and send a couple of simple set points back down to the automation system. And one other thing, it's much more flexible. The case that we've had with this dynamic VAV optimization solution is that while the original intent was energy efficiency, as part of a COVID response, we were able to consider really at its heart what we're doing is changing what our priorities are and how we control the ventilation system. If our priority is no longer energy efficiency, but instead mitigating airborne virus transmission risk, it's the same concept, but we have a different target. And once again, it's something that machine learning can deploy a bit easier for us. So to make the graph a little bit more colorful and put it into perspective a little bit, with these VAV systems, if you think about where the energy inputs are, you've got a fan that's pushing air through the system, you've got energy to cool the air, and in many cases, energy to heat the air as well. Not all the time, but quite often you'll have this reheat. So to keep a space happy in a variable air volume system, we need to put fresh air through it, and we need it to be conditioned. And what we see on this colorful graph are all of these different ways or different points along a spectrum that achieve the same end goal, but at different levels of energy consumption. On the far left, we're looking at a scenario where we're supplying very cold air. So we don't have to use as much fan energy because our variable air volume boxes they're not going to be asking for that much because it's so cold, but we have to use more energy on our chiller or cooling system to make it that cold. And if that's the case, we probably have more zones that need reheat because the air supplying is colder than that zone needs. On the right-hand side, it's the opposite. That's when we're supplying warmer air. So if that's the case, we're not spending as much energy on cooling, we don't have as much reheat, but our systems down the line are going to need more air, we need more fan power to push through. And what we want is to always be at or near the bottom of that curve. And that's something that changes all the time, and where machine learning can come in, solve a difficult problem, and allow the BMS, the building management system, to do what it's really good at. So with this, definitely keep an eye out on communications from Siemens, from SSRIA, about the project that we're working on in Edmonton. It's one that we're very excited about and looking forward to getting results out into the marketplace. So that's one way to control things better. How can we find a better way of understanding what's happening in the building? In a conventional system, there's a building automation, and there's already quite a bit of information available. What we can do is start to tap into that better. Have a system in place that collects all that data, and rather than relying on a person, either complaining that there's an issue or facilities management looking for a problem, which in reality they often don't have time to actively seek out to do, we let the system tell us where the problem is, what the likely problem is, and a solution as well. So an example here is just purely taking data that would already exist in most buildings, in this case for a chilled water system, applying fault detection and diagnostics to it. So you've got this big library of rules saying, here's all the things that might go wrong in this particular system. It's always monitoring what's happening at a given time and letting the building management know, all right, we had this problem, here's when it occurred, here's where it occurred, here's a description of the issue, some information about a resolution for it. And the result, there's several positives that come out of it. In many cases, from an energy and sustainability perspective, this is finding issues that otherwise go unnoticed. there's a huge amount of energy that gets wasted in buildings, and this helps define where that waste is. Because, like I mentioned, the reality is that most buildings have limited capacity to go and just actively look for improvement opportunities. It's more reactive, addressing when there's a problem or a complaint. But in some cases, the data doesn't exist already. So if we need new data, that probably means we need new sensors or some form of input. One thing to really consider as you're thinking about a smart building and smart building technologies is where that data is going to come from, and avoiding a scenario where you've got 10 different systems doing 10 different things. Anywhere that you can have one solution doing multiple things and ensuring that different technologies can speak with one another, that's a win. So what we see on here, these are enlighted sensors from Siemens, small, about the size of a quarter, that can be mounted in light fixture, ceiling, under a desk, and depending on their application, they can provide a whole lot of information. Lighting control, power monitoring for lighting, understanding of how a building and a space is used beyond just on, off, or is it occupied or not. It gets down to a much more granular level. And then even unlocking this capability of a Bluetooth network inside the building that all of a sudden allows for tracking of assets or devices or badges around the building, or wayfinding. If you think of a more complex building, a hospital, you'll have a lot of visitors or new people coming in that it's easy to get lost. If you've got this internal network that's already doing a few other things for you, and it can help people find their way around and navigate, that's a system that's doing a lot from one single sensor. So in a building, can deploy, like I said, light, ceiling, desk, and do a whole lot of things for you. So these are technologies, they're doing some good things here and there. They're helping us to be more sustainable. But ultimately, someone has to make sure that everything's up and running. And how does that affect the building operator? The same way that we've talked about earlier, it's more input, it's more data coming through. Some of that would come from the fault detection, diagnostics that I had mentioned. In other cases, it's direct user input from an app that lets the building operator know there's a problem here, there's an inefficiency here. You can go and do something about it faster. So they can go and find that, resolve it, and the end result, it's energy savings. I mean, there's comfort improvements as well, and better comfort conditions. Tenants are happier, but energy is a huge part of it. There's, like I said, a massive amount of energy that gets consumed in a building, but doesn't really do anything for us. It's wasted. It's that over delivery of conditioning. It's maintenance problems that go unnoticed. So these technologies and these tools allow us to address those a lot more efficiently and unlock that energy potential. And the last one for me, if as you're in a building, if you start to think about it, all the energy inputs and outputs and where they might be fighting with each other, wasted, where a decision could be made better, you'll see it top to bottom. It's all over the place. And a smart building and smart building technologies allow us to capture all those inputs, make better decisions going forward. And that way, at the building level, we can be as efficient as possible, and we can keep it that way. So I'm going to pass it over to Wade, and then we can start to go through some case studies about the technologies that I mentioned, but also zoom out a little bit and find out how does this actually connect to the grid and going beyond. So Wade, I'll pass it over to you.
Mark, thank you very much. I am just taking over your screen sharing, and I just want to get some feedback that it went smoothly.
We're just seeing it was the notes section at first that came up.
Right, so I shared the wrong screen. Sorry about that, guys. This should be it.
Yes, that looks great.
Awesome. So Mark, thank you very much for all the overview that you presented. And really just what I wanted to present here is a build up on top of kind of what Mark was talking about, right? So when we've been thinking about how to render our buildings more efficient, a lot can happen from efficiencies at these different stratas of intelligence of the building, right? Within the actual systems themselves, when you're thinking of your mechanical room, when you're thinking of the systems themselves, and Mark summarized that very, very well. But also now when we're allowing these systems to start communicating with one another so they can make the right decisions happening at the building level. You can optimize and push the boundaries of physics by so much, right? You can optimize a chiller by so much until the boundaries of physics can. So how can we start leveraging additional data to render this building or a building more efficient? A lot of, and the reason why it's so important to focus on the efficiency aspect and the sustainability aspect of buildings and intelligence, because a byproduct of smarter buildings can be comfort of occupants, can be, as Mark highlighted, potentially facility managers having just a better experience predicting maintenance and optimizing their systems. But a very important aspect of it is the energy efficiencies, because this is where we believe lies the business case to justify smart building transformations. So this is where you hear, for example, in provinces out east, they're talking about smart and green buildings. It's no longer smart buildings, because from a business case, it's something that is very, very important. And what we're seeing here on the screen is basically just a very beautiful graphic that shows all of these different systems, how they could potentially start interacting with each other to start thinking, how can we drive sustainability, thinking outside of the box? And just citing a very simple example, can we start leveraging information from a security system like we're seeing on the screen, access control, to start commanding and anticipating energy loads on the HVAC side? Can we start talking and opening up the data lake of workplace applications, maybe booking systems, to understand which rooms are booked when, and asking our building systems to behave accordingly? And in similar fashion, how can we start looking into the actual third-party system integration, things beyond the building itself that typically we don't think of? How can we bring in relevant data, as Mark was mentioning? It's the right amount of data so we can make better decisions, right? The era of just getting more and more data, more and more information, it's kind of gone. And I remember back in, let's say, 10 plus years ago, people wanted to put sensors on water kettles and microwaves and fridges. Now it's no longer about that. It's getting the right piece of information that is actionable. And what I'm going to do here is I'm going to walk you through some examples where we've done something like that. The first example is some work we've done with AT&T. And the work here leverages the Enlighted system and Enlighted sensor that Mark kind of briefly spoke of. And what we've done with AT&T is we looked at all of their different locations. So both when you're thinking of their retail locations and their office space. And we leveraged our smart sensor that, typically does lighting control, that is capable of getting a lot more data and granularity in terms of occupancy, in terms of being able to potentially use that for RTLS features and go beyond. But the core use case, of the atomic use case that it was used for, was understanding the behavior of people. And that's something I want to focus on a little bit, because in our world, we love technology, and sometimes we speak a lot about technology, but we have to center it back to the people aspect, right? So people are at the center of these buildings, and that the focus has to come back to the people aspect, understanding how people behave, how do they navigate in a space, but also how do they feel or interact with the space. And I'm going to talk about that in the next slide. So the data that we gathered working with AT&T taught us, first of all, we changed control of the building systems all based on occupancy. But the first thing we realized getting all of this data is the behavior of people, the timing of when people show up, are completely different from what the buildings was designed for and set for. In a lot of retail space, people were showing up at different times. Some offices that were optimized for earlier in the morning, people are actually arriving around, a couple hours later. So optimizing and controlling the building systems accordingly was able, even those couple hours a day of shifted set points, resulted in a lot of energy savings. And you see some of them here captured $8 million a year in energy savings. So this was a very immense lesson for us to say, hey, we design building for a certain use and understand how we want people to use them, but then we realize that they're being used differently. And being able to be flexible and future-proofing our systems for that is something that is going to be very, very important. And now with COVID and the whole disruption of maybe some spaces that will be repurposed, that flexibility needs to be there, because the way these buildings were originally designed for might completely change. We're hearing about different ways to use office space. We got to be able to adapt for the future workspace. So the other thing wanted to highlight is, we spoke around how people navigate a space, when do they come to certain offices, etc. There's another aspect, which is kind of your user experience app. So on the screen, you're seeing screenshots from the Comfy app, which is our workplace experience application here at Siemens. And it's an application that allows you to book rooms, get navigation, control the systems. It's something that we give for users to give them a window into a smart building. And originally, the first use case for this application was just this screen that you're seeing here called temperature. And the first question that would say, warm my space, cool my space, or I'm comfy, hence the name Comfy. And the reason why this was such an important aspect of this app, and that was the first aspect of the app actually, is because we learned that an objective measurement, and that's something you kind of know, right? We always knew that you have colleagues that feel temperatures differently. So an objective measurement, it's 21 degrees, 22 degrees, is experienced differently by different people in an office. So that gave us a metric, a data point that was completely invisible to us. And it's not about where people are. It's not about what is the temperature right now or what did the engineer set it for. It gave us an insight into how do people feel, and a subjective measurement that was completely invisible to us. So what we're able to do with this data point is learn two things. One, in large open spaces where we have people arguing about the thermostat, we're able to go back to some clients of ours and recommend how they can potentially restructure their floor plan and have, rather than grouping people per maybe team or department, maybe comfort is more important. Maybe you want to group people comfortable with warmer temperatures in that northeast corner of the open space, and the southwest corner is a cooler temperature, for example. The other aspect that we learned from doing that was, how do people experience temperatures in the winter and in the summer? In the summer, you have your AC blowing cold air, somebody coming in from outside, and there's a lot of heat. They're going to feel that the office is actually cooler than it actually is. Same thing in the winter, and we experience that in Canada all the time. You go in, feels very hot, and that's because of the contrast of temperature. So getting that information allowed us to push the set points in the first couple hours of the morning by a couple degrees, because we realized that it takes time to readjust and readapt. So the temperature can be a little bit hotter on the first couple hours in a summer's day, because the relative experience is now different, and people, when they're coming in, they don't feel that shock of colder temperature because it's a relative experience, and that translates into immediate energy savings. So this is why kind of these applications that are very attractive and very important, and they're being deployed mainly around booking desks, etc. There's a real value that lies in them, specifically around energy efficiency, specifically around sustainability. And that's where we see the rich amount of data being present. And another example that I wanted to highlight here is to switch gears, right, from a commercial building to maybe something like a hospital. So in a specific hospital work in California, in southwestern states, we integrated the admit discharge transfer system, or in some cases admission discharge transfer system, also known as ADT, which is the repository of which room is booked, which surgery suite is booked, by whom. And we took that information into the building management system. And that allowed us to basically anticipate patients coming into rooms, be aware that certain rooms or suites are going to be empty or vacant for a couple of weeks, and completely override their occupancy set points to basically unoccupied and save energy there. And from a surgical suite aspect, that integration helped us in giving surgeons their preferred set points, so rooms can start cooling down a couple hours before, rather than having those rooms running even when surgeries are not happening, and having different set points for different type of surgeries or different surgeons. Another thing that we can just highlight here is, as also part of these integrations, the nurse call systems were integrated to allow patients to start changing temperatures. And that was done in two ways. One, through their pillow speaker that you're seeing here. Two, through the multimedia system, where just like they can go to a sports channel, they're able to use their TV screen to change temperature. And the key of that integration was to increase comfort of patients. Free nurses allow them to do what they do best rather than have them back and forth controlling temperatures. So having higher precision in kind of the comfort of patients allowed them obviously to recover better, but just the comfort and the experience changed completely. But it all boils down, again, to the energy savings that were done through the ADT system, which was in that specific case around 100 grand a year of savings. And now we kind of talked about within the building, right? But let's start thinking outside of the building. And this is kind of to introduce the topic at a high level, right? So we're speaking about smart grids, and we're thinking of all these distributed energy assets that are potentially one day going to decentralize the way we look at power. So the same type of logic is being applied at the grid level. But it's very important, that's where you see smart building and industry in this little corner, to have that communication to the grid edge, where the optimization happening on the grid side, on the power side, is also happening in communication with the building management system. So the building can start making decisions at a higher level. And the reason we want to start looking into that, there are a couple concrete examples that we're going to highlight, right? So first of all, power generation is something that we're seeing a little bit more traction, right? Where a lot more customers and clients are coming to us saying they want to start having, from a sustainability, from a resiliency, from a, maybe in some cases, marketing, the ability to have some power generation aspects on-prem. The other aspect as well is power storage, right? That is changing in terms of batteries are becoming more cost effective and more accessible. There are a lot of conversations happening on what do you do with gensets? Is it the time to switch to batteries? And that's a complete conversation on its own. Also, in terms of EV, and that's something we want to focus a little bit on, because if everybody switches to EV tomorrow and we're all plugging our cars, it's just not going to work. So that's something that we need to start doing gradually. The infrastructure has to be upgraded, or we're going to have to start looking at different ways of doing that. And to kind of zoom in on this specific subject, this is where, by understanding the data that resides within the building system on the behavior of people, when they're showing up, what they're doing in the building, that is very rich data that will allow us to potentially anticipate the demand on something like a EV car infrastructure. So having the ability to have a consolidated, intelligent building capable to, one, anticipate that, two, to action that sudden demand by maybe asking the BMS to reduce comfort set points. And you know what, guys, we have such a high demand right now. Temperature's got to be 23 degrees right now. It's going to get a little bit warmer, but that's something we have to do just to manage the load. So these are things that have to happen, especially in existing buildings that are looking to evolve and start adding some of these things into the buildings. And thinking outside of the EV infrastructure as well, when you start thinking of your PV solutions, battery solutions, etc., you will need to have a type of brain that is residing and in conjunction with the building management system to make these decisions in real time, right? There's a storm coming up. Maybe there's going to be an interruption in the utilities. So you know what? We want to make sure the batteries right now stored, and our priority is resiliency because of the storm that's coming up. And maybe it's a discussion around purely energy efficiency and controlling how much can cars and car owners charge to make sure the demand is not too excessive. And lastly, how can we start having as much of that automated that the data around occupancy and when occupants arrive and leave can be used to optimize how things are running in the building. And lastly, and this is kind of the last thing I'll touch on, is an activity we did with, which is called Smart Grid Atlantic, and it was a partnership done with the federal government as well as NB Power and Nova Scotia Power. And the goal of that activity was twofold, right? One, in areas where there's First Nation communities, was to use the microgrid technology to create self-sufficient smart energy communities. And that was done here where you can kind of see the little bubbles. The other aspect of this was developing something called Energy System Platform, or ESP, to create a smart grid community, and that was done in Nova Scotia. And the goal of that technology was to basically test the concept of how utilities will be in the future and how they will be moving towards becoming just like Uber. Uber doesn't own any cars, rather they have a platform that allows transactions between car owners and customers. So the utilities of the future, if we want to start thinking of what the future is looking like, might become exactly that. Maybe in certain pockets of the country, maybe in more than that. But they will have to start managing the communication of energy between building owners and facilities that are capable of producing on-prem decentralized energy, that they're willing to transact with other customers that might not have that ability. And that decentralized approach will help not only create better resiliency, but it can help also from a cost perspective as you're upgrading your utilities to keep up with the demand. So that's kind of more as a opener on a different topic that I just wanted to end with. And with that, I want to thank you guys, and maybe I'll stop sharing. And I believe, Morgan, you are up next.
Yeah, so thanks so much, both Mark and Wade. Definitely appreciated the, that definition of smart building, and understanding that there's quite that spectrum of intelligence, really. So I will now actually pass it over to Morgan McDonald, who works on high performance buildings and process innovation with Ledcor Construction. And he'll briefly share his perspective on smart buildings and how it's been integrated with Ledcor. Morgan has a background in renewable energy, carbon finance, and sustainability education, and he currently volunteers with Living Future Vancouver and the Canada Green Building Council. We're also very grateful to Morgan, who shares his expertise with Surya in support of our project review process. So go ahead, Morgan.
Okay, thanks very much, Pam. Can you see my my screen? It should say smart buildings.
Yep, we see it.
Okay, excellent. I will be brief. I want to save some time for discussion, but yeah, I wanted to give the contractor's perspective. So let's get into it. Ledcor, if anyone doesn't know, very large company, probably one of the most diverse construction companies in Canada. A lot of different sectors. I work with the buildings group. Okay, so I work on high performance buildings and supporting innovation. A couple of projects that we have that I would say are, high profile with some smart building technology in them right now. 1133 Melville, also called the Stack in Vancouver. This is an Oxford project. We're a construction manager. When it comes to sustainability, I mean, the things that they're really profiling are that they're targeting LEED Platinum, targeting zero carbon. This is in the design and construction of the building. It also has a lot of smart technology, and that's where I see these as stacked on top of each other. No pun intended. But you can use a lot of sort of dumb technology to get the energy consumption low in a building in the first place with good insulation and windows and whatnot and efficient systems, and then have all these operational features with smart technology to make it run even better. Similarly with Vancouver Centre 2, also in Vancouver. This is a GWL project we're building for them. Again, it's sort of that, as Wade said, the green and smart, right? It's targeting LEED Platinum, it's targeting WELL Gold, it's already got wired silver certification. And that's an interesting one that actually provides a bit of transparency and third-party sort of sign off on some elements. It doesn't tell you exactly how smart a building is, but it tells you it has some of the infrastructure that can support a lot of what a prospective tenant might be interested in. So I just took a screen grab. You can see it's all public information, all the buildings that are wired certified, and it tells you some of the just sort of nuts and bolts of what's in this building, so that you can think of what features you might want to be able to get out of it if you're a tenant there. So we heard a great definition of smart from Siemens. I've got an even simpler one. You got to have these three elements: infrastructure, integration, and automation. And I would say, smart building technology is still evolving. It's not mature yet. And so some people get really fixated on one of these elements and so they can overlook the others. If you don't have them all, you can't take advantage of all those features you just saw, right? Sure, maybe you have a whole bunch of data points on a dashboard that you can see, but if they aren't integrated and connected, you don't have any tools to play with it to make the data work for you. And so that's a pitfall that we sometimes see, and have to make sure that the whole system is being thought of through design and then into construction. So briefly, some of the sort of considerations that I think we need to pay attention to. I really liked how Mark, you opened with only solve the problems that are needed. So be wary of the inverse, solutions that are for problems you don't have. It's common for people that are very excited about their technology to insist that you need it, but maybe you don't, and to make sure you have a good analysis of what is the right tech for your building. Beware of startups that can't deliver, and not just startups, but also just new offerings, right? New services. And if you are someone who is delivering new services or are a startup, keep in mind that there is going to be that conservativeness in the market. So how can you show and prove that what you have works and that it's an appropriate fit? You might need to demo or have some early access to the technology before someone dives in and signs you up. Be wary of the hidden energy and greenhouse gas footprint. We chatted a little bit about this in planning for this event. It's one thing that I think about. Increasingly, we're being asked to look at the full life cycle greenhouse gas emissions of a building. And that includes the hidden stuff, the stuff that's offsite. So AI, machine learning, great, but I know that has a lot of processing power behind it. So where is that energy coming from? Is it a clean grid? Do we even know how much energy it is consuming? Is it a reasonable spend on energy and carbon for what's being saved from the service it delivers? Probably it is. If it's cost effective, it's probably also energy effective, but not necessarily. And so that's something I think worth looking into. And increasingly, I expect people will ask for it. So great to get ahead of it if you can. Evolution of the industry and compatibility, right? Think about these buildings we're making, the two that I mentioned, 5 years in design and construction. I'm sure smart technology will have already evolved a couple of generations by the time it's built. And so always think about future and forward and backward compatibility, and what is how long is this system going to serve my building? At the same time, maybe you looked at something and it didn't pencil, and that was 2 years ago, 5 years ago. Well, because it's evolving so quickly, sensors are getting smaller and cheaper. Re-look at those old business cases and see if perhaps now they make sense, whereas they didn't before, because it is evolving so quickly. And finally, planning and procurement, we saw those wonderful diagrams showing how many systems can be integrated. The more systems you're connecting, the more different disciplines and subtrades and suppliers are now kind of entangled in the product and in the solution. And so also sort of a cautionary tale from some other projects we've seen. Make sure this is clearly understood. You've reviewed the compatibility and the completeness. There's no scope gaps, and that everyone knows what's expected of them and how their system needs to be compatible and connect. Make sure, risk, who's responsible for what kind of performance of which elements. Make sure that's not only clear in your contracts, but clearly communicated as the whole team is working this thing through, because there's going to be a lot of players that come together to make that final system. And I'm going to leave it right there. We've got 10 minutes, and I'm hoping I can give that back to Pam, and we'll see if there's some questions for the group.
Thanks so much, Morgan. You certainly ended off with a lot of different topics that we could start a discussion on. Maybe where I'll start though is kind of really the overarching question with regards to sustainability, being what that being our kind of main focus. For both you, Morgan, and some of the projects you've done, and even for Mark and Wade, do you find that sustainability, particularly on environmental sustainability, is a driver for clients asking about smart technology, or is it just one of those added benefits that that support the kind of the full value package?
For me, generally, I hear it more on it's the service, the comfort, some of those other attributes that that Mark and Wade mentioned. It's tech compatibility with what I want to get out of my building. Maybe for some operators, it's also one of the elements in their, multifaceted energy plan. But in my world, it's the envelope and the nuts and bolts of the building that are the primary sustainability drivers. And then this is okay, now you've got a building, what are you going to do with it? Let's tune it and let's make sure it's running as well as it can.
Yeah.
Yeah, I'd agree with that. I think in most cases, there's interest in smart building technologies because you might simply have a building owner, building manager that has a vision of a smart building. They like the way it sounds and they maybe don't even know what it means. Or they want it for comfort improvements or meeting a standard. And then separately, you might have them coming to you and say, I want to be more energy efficient. And you might have a solution that delivers energy efficiency through a smart technology, but very rarely, to date anyway, have we seen cases where someone has come forward and said, I want a smart technology to be more sustainable. I think there's opportunity for a lot of overlap, but generally not viewed that way, not just yet.
Yeah, and definitely I can echo those two statements. And I think kind of what I alluded to is that the sustainability aspect can be the catalyst or the business case driver for a lot of these projects, where sometimes the newer technology, flashy things are cool, people look into it, but maybe some clients aren't willing to pay a premium for something that makes them just a little bit more comfortable. But now if you can add a sustainability angle to it that can be translated into actual dollars of savings and impact on the environment, then it's a completely different story. And I think that is the transformation that we have to go through as well.
And Morgan, one of the other kind of pieces you touched on in your last slide there was with regards to the collaboration required and all the different trades and professions that are ultimately involved when you start integrating smart technology. And something that we look at too is that when we're looking at accelerating the adoption of low carbon solutions, we recognize that the workforce is a key component of getting us there. It's not just having new technology and demonstrating that it works or it's valuable. Where do you see on your end, I guess it's two full questions, like there's the collaboration side, but where do you see some of the skills gaps or trainings gap that needs to be addressed to be able to, really realize the end of the spectrum of the smart building spectrum?
Yeah, it's a good question. Certainly, the first one that comes to mind is just you're kind of, you have to follow the procurement path, and so if it wasn't well articulated in the sort of procurement intent, it's not going to happen. So sometimes what we're seeing is a need for the owner to have a design assist partner to help even just define what the solution ought to look like, so that it can follow the next chain of events to have some competitive bids and then have it all come together. There's a role called master system integrator, which we're seeing increasingly, which is someone who plays that role of making sure all these separate parts work, and that's conceived of in the design stage, because it's hard to, it's some of these things you miss an opportunity and it becomes a retrofit project before you know it.
Right.
I'd say that's the key one. And then after that, it's just learning, everyone else learning from the increasingly sophisticated offerings that are out there from companies large and small. It's making sure we know what's possible that we can then incorporate it into our projects.
Perfect. And Mark, from your end, when you're integrating or implementing a technology into a building, are you providing that training for the operator?
Yeah, definitely. And this is true for just about any energy measure. Our goal is that they stick, right? And if you go in, implement an energy change or an improvement, and walk away, the day-to-day building operator, if they're not informed of what's happening, what the change was, why it was changed, it's very easy for them to default back to the way things used to run, what they're used to seeing. So they have to be fully aware of what's going on and what they're left with. So they have to know exactly what went in, how it's intended to operate, so that they can make sure it's doing its job and that those energy savings and benefits persist.
Yeah, perfect. Wade, did you have anything to add on the training front or upskilling? It's not even just training. It's, what are the new skills that I suppose we need to prepare our workforce for, just to, on both ends, to integrate new technology and even to manage those buildings?
Yeah, no, absolutely right. In terms of the training aspect, you're thinking people have to start looking into things that they're not necessarily more comfortable with, or the software that they're using to only do, let's say, HVAC control now might have to do a bunch of other things that are integrated too. So there's definitely a training aspect to it that we're all going through, right? So both technology providers, integrators, and customers and clients as well. And as far as making sure everything fits together, it's something that's very important as well. And how do you de-risk that? So the more conversations can happen at an early stage, and the more technology providers are also at the table, the more some of these things can be de-risked than those technologies being, let's say, commoditized and then procured separately, and hoping that, like puzzle pieces, they can work. And sometimes they do, but a lot of times some of these conversations are very productive.
Yeah, for sure. And I just have a question in from the audience here, and I was just going to mention that, of course, audience members, please feel free to add your questions into the chat box. So Doug adds to that, just asking what role might colleges, universities, and polytechnics have in that kind of training and education component, and what changes need to happen in the curriculum. This might be outside of your guys's realm, but do you have any thoughts on that?
Yeah, I mean, I can chime in there, and I think it comes from that last question, skill sets. You've got some new skill sets that come into play, all these different devices talking to each other. It's new potentials for problems. It's not a leaking valve anymore. It's a bad firewall connection that the building operator has to maintain or address. But the leaking valve problem is still there, right? They're just finding out about it through fault detection instead of doing their daily rounds. So I'd say it's a new set of skills that have to be brought into those existing training programs for HVAC technician, building operator roles. And then beyond that, for any colleges, universities to just revisit on a very regular basis. I mean, Morgan talked about how rapidly this is evolving. I'm personally on an academic board for a college in Ontario, and part of that is various industry members coming together and talking to the college about, this is what we see happening in the market. This is where we see a skills gap, or something that we think should be brought into curriculum that will translate into jobs at the end of the day. But I think the frequency, it has to be really rapid. That one that I participate in right now, we meet quarterly, and I don't know that that's enough because things are changing so quickly. So bringing in industry input and feedback for those higher ed institutions, I think, is really, really necessary.
Well, that brings us right up to 1 o'clock. I want to thank all three of you. I'm sure it's a conversation we can continue to have for some time. But thank you for sharing your expertise with us today. And I do think this is a conversation that at SRIA we will continue to have and continue to host events on. I think it's an area that Alberta is actually poised to show a lot of leadership in. I'm not sure if folks are familiar, but St. Albert, just a neighbor of Edmonton here, was actually recognized for having the third best smart city plan in the world, following Vienna and London, which is pretty incredible. And then the Trade Commissioner Service of Canada also developed Alberta Smart City Directory, which actually features a number of SRIA members as well. So it is a conversation we will continue to bring you up to date information and just some kind of thoughtful discussion around. So thanks again, everyone, and I hope you have a lovely rest of your week.
Thanks, Ben.
Thank
Thanks,
you.
everyone.
Yeah, thanks everyone.